We talked about quantities in the previous video. We are now going to talk about the units that follow these quantities. I don't normally do this, but I will start this video with a very stern warning. Any physical quantities demand a unit. If I ask you to compute how far a car has traveled, we are talking about distance or length here, and you answer me 2, and that's it. I will reply you back to what? To kilometer, to meter, to centimeter? Of course they are physically different. So you see here that the unit which follows the number makes a huge difference. In the test or exam, if you present the answer in the wrong unit, or even worse without unit, your answer will be deemed wrong. As simple as that. The next question is, okay, you want the unit, fine. But what sort of unit do you wish me to present in my answer? If it is 2 km, can I put down 2000 meter for example? Well, to be frank, I don't really bother about this. 2 km is physically the same as 2000 meter. I'm fine either way. Of course, it won't be fine if the answer is supposedly 2 km, but you forgot to write the K and you only put down 2 meter. That's completely wrong. Nonetheless, it is still worth examining the different unit systems there are in physical and engineering sciences, particularly, and some of you might have heard of this jargon being mentioned before, with regards to the International Unit System, or SI unit in short. SI units, in essence, is about writing the units of physical quantities using the units of base quantities. I present the base quantities and their respective base units in this slide for your quick reference. Now, what do I mean by this? I think it is much easier to elaborate using example. By the way, before we proceed to the example, in case you are wondering why it is known as SI instead of IS unit system, that's because the abbreviation SI refers to how the system is called in French. No, I shouldn't even attempt to pronounce its French long form, but as you can see from the slide, in French, the word system precedes the word international, hence the short form SI. Now this is the question. A 1.0 gram object undergoes a 2.0 meter per second square acceleration. If the formula to compute a force is given by the famous Newton's law F equal to ma, what is the force acting on the object? Express your answer in SI unit. Well, I guess this is a relatively simple question. The relevant quantities are presented and the formula is given explicitly. Of course, the emphasis here is on the last statement. You need to express your final answer in SI unit. So here we go. F equal to ma, m is mass and that is 1 gram, and a is acceleration, which is 2 meter per second square in this case. Now let's scrutinize these quantities further. Meter and second are base units. Refer to the table from the previous slide if you forget. Hence acceleration, which is 2 meter per second square, is already presented in SI form. The mass given here, however, is in gram. Gram is of course a valid unit for mass, however it is not the base unit. The base unit or SI unit of mass is kilogram, so we need to convert the unit from gram to kilogram. We know well that 1 kilogram is 1000 gram, or to put it the other way around, 1 gram is 0.001 kilogram, or 10 to the power of minus 3 kilogram. So now we have all the quantities in our calculation consistently presented in SI form. I'm sure you shouldn't have any problem multiplying the two numbers, and we have our answer here. That is 2 times 10 to the power minus 3 kilogram meter per second square. This is perfectly acceptable answer in SI unit. You can choose to stop here and get your full mark, but to say kilogram meter per second square is rather a mouthful, isn't it? So physicists came up with a unit called Newton, named after another giant in the history of science, Isaac Newton, to replace kilogram meter per second square. So you may say that Newton is actually a derived unit in the same sense as force is a derived quantity. Remember we talked about this base and derived quantities in the last video? In short, Newton becomes the SI unit of force. But remember, you can only use Newton to replace kilogram meter per second square. Where we choose not to convert from gram to kilogram, we will end up with the answer 2 gram meter per second square, which is itself is a physically valid quantity of force. It is just not written in SI unit, and for sure, it is not equal to 2 Newton. Now, of course, I'm assuming that most of us in this class is taking our physics from scratch. In reality, we won't spend 5 minutes working on this problem, recalling what is the SI unit of mass or elaborating on whether things are already in the SI unit or not. With practice and practice, converting quantities from one unit to another will just come naturally. And in a couple of weeks' time, you will be able to do so without battling an eyelid. Are there any other unit system besides SI unit? Sure there are. CGS unit system is very much similar to SI unit, except that its so-called base units for length is centimeter and for mass gram instead of meter and kilogram. In Singapore, our physics education system is mostly conducted in SI unit, but our American friends are probably learning to write physical quantities in terms of feet, pound, and second, or FPS in short, as the base units for length, mass, and time respectively. And of course, there are other special unit systems used by theoretical physicists to help simplify their calculations, such as this so-called natural unit system. Don't worry about all these unit systems. As far as fundamental in physics 1 is concerned, we will be dealing mostly, if not only, in SI units. I started this lecture video with a warning, and I will end this video with another warning. Be careful when you are dealing with multiple quantities whose units are from different systems. Make sure the units of all the quantities are consistent before doing any computation involving them. What do I mean? Well, say in reference to the example we just went through, you are tasked to compute force. The mass is in pound, but the acceleration is in meter per second square. You can of course just multiply the two numbers and end up with an answer in pound meter per second square. But I strongly do not recommend you to do so. Strongly do not perform calculation in mixed unit system. And to further emphasize my point, I present this particular disaster which I remember created quite an embarrassment to NASA at the time, not to mention the huge financial loss, $655.2 million US. Do read up the article through the link I gave here and you will understand what I mean.